Find a possible solution for f of x, given that f of x is the integral of dx over the quantity square root of x plus quantity square root of x plus 1. Okay. This one looks, I think there's going to be some algebra involved. Okay. So first thing we think of is, I'm going to rewrite the equation, mostly as a way to stall for time so that I can think of what to do. X plus 1 square rooted. Okay, so radicals are difficult to deal with when they're in the denominator, but if we get them in the numerator, they're easier to deal with. So what we're going to do is we're going to, I think the term is multiply by the conjugate. So there's basically two things you can always do in math. You can always add 0 or multiply by 1. In this case, we're going to do the multiply by 1 scenario. So what we're going to do is we're going to multiply by square root of x minus square root of x plus 1 over square root of x minus square root of x plus 1. So when you hear the term multiply by conjugate, what they're talking about is that negative right there. That positive turns that negative, and you multiply by that. This is the same idea as the difference of squares. So here, difference of squares, and you think of something like a squared minus b squared equals a plus b times a minus b. Where difference of squares, they're talking about this side. Multiplying by the conjugate, they're talking about this side. So what we're doing is we're trying to go, we start with this, we multiply by that, and we're looking to get something kind of like this. And those squares will cancel out the square roots. That's the general strategy we're going for on this one. Whoop, whoop. Okay, so now comes the algebra. Okay, so the top part, that'll be pretty easy. So make a little equal sign, make an integrand. This will be square root of x minus square root of x plus 1. There'll be a dx over here. And now we have to FOIL these. So square root of x times square root of x is x. Square root of x times negative square root of x times 1 will be minus square root of x times square root of x plus 1. And then we'll do square root of x plus 1 times square root of x. So this is the parts that are going to cancel out, which is nice because I wasn't quite sure how to solve them otherwise. And then we're left with a square root of x plus 1 times negative square root of x. So we'll do a negative quantity x plus 1. Extend out this. Okay? So we look at this and we can see that the interior parts, ooh, man, so many decisions. Okay. These two cancel because we have a negative and we have a plus. And we are left with, and then I'm going to distribute this negative sign real quick. So we have a negative x, and then a, wait a sec, negative x, negative 1? Yes. Negative x, and the negative 1. So we're left with integral square root of x minus square root of x plus 1 all over x minus 1. Oop, change colors, just because it's easier to cancel with a different color. And this will give us square root of x plus 1 minus square root of x dx. Because we're left with this negative 1 here, which then just flips the signs. Not too big a deal. Okay, so now we can totally do this. This is not, it's not exceedingly difficult, but it's still fraught with peril. Okay, so we're going to rewrite this again. Oh, we've rewritten this so many times. So many times. X plus 1 to the 1/2 minus x to the 1/2 dx. Now we're just left with a power rule. Actually, you kind of have to do a substitution with this one. But don't worry, it's fine. You're fine. You're fine. Okay, so then we have x plus 1 to the 2/3 minus x to the 2/3, because 1/2 plus 1 is 1.5. What? Not 2/3. It's not 2/3 at all. It's 3/2. This is what happens when I get ahead of myself. 3/2. 1/2 plus 1 is 3/2. And then we're going to have to multiply by the reciprocal, which will be 2/3. We can factor out the 2/3, and we have 2/3 times the quantity x plus 1 to the 3/2 minus x to the 3/2. There we go, 3/2 bracket. Okay, let's see if that's anything close to one of the answers we might have. Bum, 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 bum. Straighten out just to make it look prettier. X plus 1 to the 3/2. Haha. Conveniently, it's the bottom one too, so it's easy to see. So there and there. So the answer will be 2/3 times quantity x plus 1 quantity to the 3/2 minus x to the 3/2. So to backtrack real quick, we were given this integral, incredibly difficult, very frustrating, kind of terrifying. We have a couple radicals in the denominator. Not quite sure what to do with those, but we're like, okay, let's try multiplying by the conjugate. Multiplying by the conjugate is the same idea as difference of squares. You're just starting from the other end and working backwards. Or forwards, I guess. I don't know. Are people on the other side of the world standing upside down? Or are we the ones standing upside down? Mysteries of life. Same idea with conjugate or difference of squares. So we go through multiplying by the conjugate, do some algebra. We find out that it all simplifies pretty well, and we're left with the power rule here. We do have to consider substitution here with x plus 1, but it turns out just to be 1, so we're fine. And after the power rule is done, we're left with multiplying by 2/3, and we're raising to the power of 3/2. And then that gives us our answer. So that's how I would approach this problem. Hope it helped you a little bit, and I will see you on the next problem. Go team.